Module 01, introducing Revit as a BIM tool. This module lays the conceptual foundation for everything we'll do in Revit MEP. It's not just about software, it's about understanding the BIM philosophy that drives it. We begin with an introduction to BIM, Building Information Modeling. BIM is a process, not a product. It's about creating intelligent models that integrate geometry, data, and workflows across disciplines. We then ask, what is BIM and what does it mean? It means shifting from isolated drawings to coordinated models. Every element carries meaning and every change ripples across the project. Next, we explore the benefits of BIM, improved accuracy, better collaboration, reduced rework, and enhanced lifecycle value. BIM isn't just efficient, it's transformative. We then look at what BIM will deliver, from clash detection and quantity takeoffs to facility management and digital twins. It's about outcomes, not just drawings. We introduce BIM-enabled tools with Revit as the centerpiece. Revit supports modeling, documentation, analysis, and collaboration, all within a unified environment. Then we ask, where does Revit fit? Revit is the engine that drives BIM workflows. It's where design intent becomes coordinated, documented, and ready for construction. We also explore who BIM is for and which of them will use Revit. Architects, engineers, contractors, facility managers all benefit from BIM, but Revit is especially critical for design and coordination teams. We examine industry drivers, mandates, standards, and client expectations that are pushing BIM adoption globally. Finally, we introduce levels of BIM from basic 3D modeling to full lifecycle integration, and we discuss the implications on teams and workflows, including fees, deliverables, contracts, and insurance. This module is about mindset and context, understanding that Revit is not just a tool, but a gateway to smarter, more integrated project delivery. Introduction. This lecture positions Revit within the broader building information modeling BIM ecosystem and clears up some common misconceptions. BIM is often misunderstood, even by those who use it. It's not just a tool or a trend, it's a methodology that reshapes how we design, collaborate, and manage buildings. We explore the principles and workflows behind BIM and how adopting this approach affects everything from team structure and project management to client communication and facility handover. Revit plays a central role in this ecosystem, offering efficiency gains and enabling data-rich collaboration across disciplines. But BIM isn't just technological, it's cultural. It challenges traditional workflows and demands new ways of thinking. We also touch on the lack of universal ownership or definition in BIM, which has led to slow standardization and some confusion. But as best practices mature, BIM will become as commonplace as CAD once was. In the short term, the shift to BIM can be disruptive, but the long-term rewards, better coordination, clearer deliverables, and stronger stakeholder alignment make it essential. This module is about grasping the why behind the tool, understanding BIM not just as a concept, but as a catalyst for smarter, more integrated project delivery. Objectives. This module sets out to clarify key concepts and prepare you for the strategic use of Revit within a BIM framework. First, we aim for clarity on the meaning of BIM and how it differs from traditional CAD. BIM is about intelligent modeling and integrated workflows, not just lines and layers. Second, we emphasize that BIM is bigger than Revit. Revit is a tool within the BIM ecosystem, but BIM itself is a methodology that spans design, construction, and operations. Third, we explore the benefits of BIM, from improved coordination and reduced errors to enhanced lifecycle value and client satisfaction. These are the reasons why BIM is being adopted globally. Fourth, we introduced the UK government's BIM maturity levels, which help define how deeply BIM is embedded in a project, from basic 3D modeling to full data integration and collaboration. And finally, we examine the implications of adopting BIM on team structure, workflows, deliverables, contracts, and even insurance. BIM isn't just a technical shift, it's a professional transformation. This slide is about setting expectations, helping you understand not just what you'll learn, but why it matters and how it will shape your role in the built environment. What is BIM and what does it mean? Let's start with the core question: what is BIM? BIM stands for Building Information Modeling, but it's more than just a digital model. It's a methodology that integrates geometry, data, and workflows into a single coordinated environment. BIM enables us to design buildings as intelligent systems, where every wall, pipe, duct, or circuit carries embedded information. This transforms drawings into data-rich models that support analysis, collaboration, and lifecycle management. It's important to understand that BIM is not a product or a brand. It's a process, one that reshapes how teams work together, how decisions are made, and how buildings are delivered and maintained. And while Revit is a powerful BIM tool, BIM itself is bigger than Revit. It encompasses standards, protocols, and practices that guide how information is created, shared, and used across disciplines. This slide is about grounding our understanding, recognizing BIM as a strategic shift in how we design, coordinate, and communicate in the built environment. Why do we want to change things? This slide gets to the heart of why BIM matters and why the industry is shifting away from traditional workflows. Across the project lifecycle, from brief and concept to handover and operation, we see significant data loss at every stage. Whether it's due to disconnected tools, fragmented communication, or manual transitions, this loss can account for up to 20% of total project effort. Each red bar in the graph represents information that's lost when moving from one phase or stakeholder to the next. That's wasted time, duplicated effort, and missed opportunities. BIM aims to plug those holes. By collating and transferring information in digital formats, BIM ensures that data flows seamlessly from design to construction to facilities management. But for BIM to work, the software tools must communicate either directly or through common exchange formats. That's why interoperability and standardization are critical. This slide is about motivation. It shows us that the move to BIM isn't just about technology, it's about efficiency, continuity, and collaboration. It's about stopping the leaks and delivering smarter buildings. Why CAD wasn't enough? This image captures a familiar scene: shelves overflowing with rolled up drawings. It's a visual reminder of the limitations of traditional documentation. When traditional computer aided drafting and formats like PDF were introduced, they were hailed as solutions to this clutter. And yes, they reduced physical storage, but they didn't solve the real problem: information retrieval and coordination. The logistics of finding the right drawing, verifying its version, and coordinating across disciplines remained cumbersome. The issue wasn't just space, it was access, accuracy, and integration. BIM changes that. Instead of static files, we work with dynamic models. Instead of searching through folders, we navigate intelligent views. Instead of isolated sheets, we collaborate in real time. This slide reminds us that digital transformation isn't just about digitizing paper, it's about rethinking how we manage and share information. BIM workflow and soft landings. This diagram illustrates the BIM workflow across the full life cycle of a project, from initial brief to end-of-life operations. As we move through each stage, brief, concept, definition, design, build, handover, and operation, the quantity of information increases. BIM ensures that this data is structured, coordinated, and progressively refined. A key milestone is the handover point between construction and operation. Traditionally, this was a chaotic data dump, but with BIM, we adopt a more strategic approach, often referred to as soft landings. Soft landings means the facility manager is involved early, helping define what data is needed and how it should be delivered. Instead of receiving everything at once, they get staged data exchanges aligned with each work phase. This ensures that the operation and maintenance manual becomes a single digital source of truth, accurate, accessible, and tailored to the building's needs. This slide is about continuity, showing how BIM supports not just design and construction, but long-term building performance through structured, intentional data delivery. How is this any different to traditional computer-aided drafting? This slide tackles a common misconception that BIM is just a rebranded version of traditional computer-aided drafting. Yes, BIM is technically computer-aided design, but in practice, traditional computer-aided drafting and BIM represent fundamentally different workflows. Traditional computer-aided drafting is about drawing. BIM is about modeling with embedded intelligence. Take the example of the chair. In the traditional computer-aided drafting approach, the label chair is manually added with a leader line. It's just text, disconnected from the object. In the BIM approach, the label is a tag that extracts data directly from the element. If the chair changes, the tag updates automatically. If the chair appears in multiple views, the tag remains consistent. If you generate a schedule, the chair is counted with its properties intact. If you export the model, the data travels with it. This is the essence of BIM data-driven modeling. It's not just about how things look, it's about how they behave, how they're quantified, and how they're coordinated. And that's why the role of a BIM manager is not just a renamed traditional computer-aided drafting manager. The BIM manager oversees information strategy, not just software. They ensure that data flows correctly across disciplines, formats, and phases. This slide is about distinction, showing that BIM isn't a superficial upgrade, it's a paradigm shift in how we design, document, and deliver buildings. The benefits of BIM. This slide highlights why BIM is more than just a modeling technique, it's a productivity engine. First, speed. BIM delivers drawings faster than traditional AutoCAD because plans, sections, elevations, and 3D views are developed simultaneously as the model is built. No duplication, no rework. Second, data integration. Every element in the model carries specification and performance data. That means annotations and schedules are not manually created, they're automatically extracted from the model. Third, interconnected views. All views are interrogations of a central data repository. Change one view, and every other view updates instantly. This ensures consistency and reduces errors. Fourth, scenario analysis. BIM allows us to quickly generate multiple viewpoints, helping teams understand the impact of design decisions, explore alternatives, and make informed choices. And finally, cost and reward clarity. With BIM, we can visualize the implications of each option, not just spatially, but financially and operationally. This slide brings us back to the practical realities of using Revit within a BIM workflow. First, a critical note. Using Revit does not guarantee coordination. It's a powerful tool, but its effectiveness depends on working practices. The base model may be coordinated, but supplemental 2D information still requires management. And that's where technique and discipline come in. BIM ideology suggests a single model file acts as a central repository for all project data. Every component is modeled with precision, allowing for clash detection and integrated analysis. But in practice, this ideal isn't always achievable due to hardware limitations, contractual workflows, and stakeholder needs. Information is required in different formats at different times by different parties. What BIM does deliver is oversight, a way to maintain continuity of information across phases and disciplines. Automated view templates, graphical standards, and color schemes help ensure consistency. Revit models can also feed into engineering analysis tools, but this may require adjustments in how the model is built and how data is structured. Sometimes these adjustments run counter to traditional drawing production, but they offer long-term benefits in coordination, performance, and lifecycle value. This slide is about realism, acknowledging the limitations, but also highlighting the strategic advantages of using Revit as a BIM tool when paired with the right mindset and methodology. What will BIM deliver? This slide explores the tangible outcomes of BIM, what it actually delivers across the project lifecycle. First, 3D model coordination is assured, but for full fabrication detail, we often supplement the model with 2D graphical overlays. These are view specific and require some manual management, but with the right techniques, we can minimize risk and maintain consistency. Second, BIM enables integration with analysis tools. Some applications connect directly with Revit, allowing two-way data exchange for pressure loss, heating and cooling loads, and more. In other cases, we find common ground, understanding what can be transferred and where limitations exist. Third, tools like MEP fabrication parts enhance interoperability with other Autodesk platforms. This ensures robust data transfer from design through to manufacture, improving accuracy, cost control, and specification alignment. Fourth, BIM supports object tagging and tracking. When elements are electronically tagged during manufacture, they can be tracked through delivery, installation, and into building operations, supporting maintenance and asset management. And finally, augmented reality becomes possible. By overlaying the digital model onto the physical building, we gain X-ray vision, seeing services and systems hidden behind walls and ceilings. BIM-enabled tools. This slide emphasizes a key truth. Revit is powerful, but it's not universal. BIM workflows require a suite of tools, each tailored to specific roles and responsibilities. Revit excels at modeling and documentation, especially for architecture and MEP. But when it comes to sustainability analysis, cost estimation, construction simulation, or facility management, other tools are better suited. That's why BIM is about interoperability. We need digital data to flow between platforms, whether it's IESVE for energy modeling, Synchro for construction sequencing, or Tekla for structural detailing. The circular diagram shows how tools are grouped by discipline: architecture, MEP, structures, sustainability, construction, and facilities. Some tools, like Navisworks and BIM 360, serve multiple roles, supporting clash detection, coordination, and cloud collaboration. The goal is not to force every task into Revit, but to connect the right tools, ensuring that data is shared, understood, and actionable across the project lifecycle. Where does Revit fit? This slide maps out Revit's role within the broader BIM process and clarifies how its outputs serve multiple stakeholders. Revit is primarily used during work stages 1 through 6, from brief to handover. During these phases, it supports the creation of the Project Information Model, PIM, a coordinated, data-rich representation of the building. But even if a stakeholder doesn't use Revit directly, say a quantity surveyor or facility manager, they still rely on data derived from Revit models. As long as the information is object-based and shares a common identification system, it can be reused digitally and reliably. This is a key principle of BIM, interoperability. Revit doesn't operate in isolation, It feeds into broader workflows, including cost planning, construction sequencing, and asset management. After stage 6, the PIM transitions into the Asset Information Model, AIM, used for operations, maintenance, and long-term performance tracking. Above the workflow, we see key planning documents, the employer's information requirements, the project BIM execution plan, and the master information delivery plan. These guide how data is structured, delivered, and maintained. Who is BIM for, and which one of them will use Revit? This slide addresses a key question: who actually uses BIM and who uses Revit? BIM adoption has not been universal or consistent. Early uptake came from design authors, architects, engineers, and consultants, driven by market pressure and internal advantages. These professionals were the first to use tools like Revit, which led to the common misconception that Revit equals BIM. But BIM is broader. It's a methodology, not a software. And while Revit is a powerful BIM tool, many stakeholders benefit from BIM without ever opening Revit. For example, quantity surveyors may extract data from Revit models but use their own cost tools. Facility managers rely on BIM data for maintenance but need non-editable formats. Specialist contractors might use Revit models to refine pricing or logistics, not author content. Manufacturers may provide BIM-enabled object libraries or integrate with Revit for specification and delivery. Clients and project managers use BIM for oversight, coordination, and decision-making, not modeling. Even roles like health and safety consultants, planners, lawyers, and document managers are increasingly impacted by BIM workflows, especially as BIM reaches into operations and maintenance. The key takeaway: BIM is for everyone, but not everyone will use Revit. Some will read Revit models, some will contribute data to them, and others will interact through entirely different platforms. This slide is about inclusion, showing that BIM is a team-wide transformation and Revit is just one part of the toolkit. Industry drivers. This slide explores the forces pushing BIM adoption across the industry and why the shift is accelerating globally. The strongest driver is the client, and in most regions, the largest client is the national or local government. When governments mandate BIM on publicly funded projects, the entire supply chain must respond. These mandates create standards, protocols, and consistent expectations. And as more projects flow through the system, those standards mature and become proven, reliable frameworks. This maturity gives the private sector confidence. BIM stops being seen as early adopter technology and becomes a mainstream validated approach with a strong future. Beyond policy, technology itself is a major driver. Improvements in hardware and software make BIM workflows more accessible and more efficient. Even adopting a fraction of BIM's capabilities can justify the investment, but organizations must evaluate the promised benefits against the cost of traditional delivery and the value of new services. Education is another driver. Universities and colleges increasingly teach BIM methodology as part of core design curricula. BIM is no longer just a tool. It's a topic of academic study, shaping the next generation of professionals. There are also economic and environmental pressures. With rising energy costs and aging building stock, public bodies, councils, hospitals, universities must assess, refurbish, or replace inefficient buildings intelligently. BIM supports this by enabling accurate surveys, performance analysis, and scenario testing. For clients managing portfolios of buildings, access to reliable information is critical. BIM allows them to make smarter decisions about where to allocate limited budgets based on operational impact and long-term value. Ultimately, as the construction sector emerges leaner and more resilient, the organizations that lead the next boom will be those fully conversant in BIM technologies, workflows, and cultural implications. Introducing levels of BIM industry drivers. This slide introduces the concept of BIM maturity and the industry forces driving its evolution. Governments, especially in the UK, have played a pivotal role by mandating BIM deliverables on centrally procured public projects. These mandates have led to the development of standards and protocols, which are now influencing global markets. As more projects adopt BIM, these standards are tested, refined, and validated, creating a mature ecosystem that benefits not just public sector work, but the entire industry. This gives the private sector confidence to follow suit, knowing BIM is no longer experimental, it's proven. Technological improvements in hardware and software also drive adoption. Even partial use of BIM features can yield significant efficiency gains, justifying the investment. But these gains must be carefully weighed against traditional delivery costs and the potential for new service offerings. Educational institutions are responding too. BIM is now part of core curricula in design and engineering programs, not just as a tool, but as a methodology worthy of academic study. And with energy costs rising, public bodies managing aging building stock, universities, hospitals, councils are turning to BIM for intelligent assessment, renovation, and replacement planning. For clients managing building portfolios, BIM offers strategic insight. It enables smarter decisions about capital and operational expenditure, helping allocate funds where they'll have the greatest impact. UK BIM maturity levels. This slide introduces the structured progression of BIM adoption, known as BIM maturity levels, developed in the UK and now influencing global standards. We start with level 0, AutoCAD, the traditional design process. Here, data is fragmented, workflows are disorganized, and outputs are typically paper-based or static digital files like PDFs. There's no real collaboration or integration. Level 1, Organized AutoCAD, introduces discipline-specific tools and structured validation. While workflows improve and data quality rises, collaboration is still limited. Communication is flattened into dumb drawings and spreadsheets. Level 2, Collaborative BIM, marks a major shift. Stakeholders begin exchanging native digital formats, and models are federated, meaning they're combined for coordination and review. Standards like PAS 1192 and COBIE emerged to support structured data exchange. This level is often mandated in public projects. Level 3, interoperable AIM, is the future state. All parties, designers, builders, managers, form a digital alliance. Data flows seamlessly across platforms via a common model server. The focus shifts from short-term deliverables to long-term asset management. Contracts evolve into IPD-style agreements, and cloud-based collaboration becomes standard. Implications on team and workflow, fee and deliverables, contract and insurance issues. This slide highlights the broader impact of BIM beyond software and modeling into the real-world structure of projects and teams. Adopting BIM isn't just a technical upgrade, it affects team structure and job roles, introducing new positions like BIM manager and reshaping responsibilities across disciplines, workflow processes requiring tighter coordination, earlier stakeholder involvement, and structured data exchanges, fee structures and deliverables, as BIM shifts the value proposition from drawing production to information management, fees must reflect the added scope and long-term utility of the data. Contracts and legal frameworks. BIM introduces new liabilities, data ownership questions, and the need for protocols like the BIM execution plan and employers' information requirements. Insurance and risk management. With more data and shared models, the potential for errors shifts, requiring updated coverage, and mitigation strategies. First, BIM is not just a software upgrade, it's a shift in methodology that affects team composition, introducing roles like BIM manager, data coordinator, and information manager. Job titles and responsibilities, moving beyond drawing production to data strategy and lifecycle coordination. Project management, requiring earlier engagement, clearer deliverables, and structured data exchanges. Second, BIM changes how we communicate with suppliers and contractors. Instead of fragmented instructions, we share coordinated models and structured data, improving clarity and reducing risk. Third, BIM affects client deliverables. It's not just about drawings, it's about handing over validated models, asset data, and digital records that support long-term facility management. Fourth, BIM impacts fee structures and contracts. The value shifts from hours spent drafting to the quality and utility of the data delivered. Contracts must reflect this, including BIM protocols, data ownership clauses, and liability frameworks. And finally, BIM introduces new insurance considerations. With shared models and collaborative workflows, risk is distributed differently. That means new strategies for coverage, mitigation, and accountability, fee and deliverables. First, BIM doesn't automatically make projects more expensive, nor does it guarantee savings. While efficiency gains can reduce time and cost, they're often offset by increased expectations and added services that may be promised without additional fees. That's why it's critical for those preparing fee proposals to understand the real effort involved in producing BIM data. Overpromising can strip all profit from a job, especially when leadership doesn't fully grasp the demands placed on those delivering the work. Second, BIM introduces new roles like BIM coordinator or information manager, which carry both responsibility and fee potential. If your team takes on BIM leadership, that should be reflected in your commercial terms. Third, we must address model ownership. Unless clearly defined in the contract, the BIM model is just a means to produce drawings. If a client or contractor requests the model for clash detection or FM, should they receive it for free? Opinions vary now, but the safest route is to clarify ownership and usage rights contractually, not retroactively. Fourth, data formats matter. BIM isn't about one software, it's about interoperable data. Formats like IFC are essential for sharing information across disciplines and platforms without loss or distortion. Contract and insurance issues. This slide addresses the legal and risk implications of BIM, especially around contracts, data ownership, and insurance. First, BIM introduces new deliverables and expectations. That means contracts must evolve to reflect who owns the model, what format is required, how will the data be used post-handover. If these aren't defined up front, disputes can arise later, especially when clients or contractors request access to BIM data for clash detection, review, or facilities management. Some argue that if they paid for the design, they should receive the model. Others see the model as a separate intellectual asset. Either way, clarity at contract stage is essential. Second, BIM changes the nature of risk and liability. With shared models and collaborative workflows, errors can propagate across disciplines. That means insurance policies must adapt, covering not just drawing errors, but data mismanagement, coordination failures, and digital liabilities. Third, BIM demands new protocols like the BIM execution plan and employers' information requirements to define roles, responsibilities, and data standards. These documents become part of the contract framework, guiding how information is created, shared, and validated. And finally, data formats matter. BIM is not about one software, it's about interoperable data, Standards like IFC help ensure that information can be exchanged freely across platforms and stakeholders, reducing risk and improving accountability. This slide is about protection, making sure that BIM innovation is backed by clear contracts, appropriate insurance, and robust data standards. Adopting BIM means rethinking how we design, collaborate, and deliver. It's not just about switching to Revit, it's about overhauling team structures, workflows, and business practices to unlock the full potential of digital construction. This transition won't happen overnight. The industry needs time to adapt, and organizations must navigate internal upheaval and upfront costs. But the rewards are compelling: new revenue streams, expanded service offerings, greater efficiency, deeper involvement across the building lifecycle. Revit plays a major role in enabling BIM, especially in design and documentation, but it's only effective when paired with methodological change. BIM success depends on how we think, plan, and collaborate, not just what software we use. End of Module 01. And that brings us to the end of Module 01, introducing Revit as a BIM tool. We've explored the mindset behind BIM, clarified its distinction from AutoCAD, and examined how Revit fits into the broader BIM ecosystem. We've looked at workflows, deliverables, team implications, industry drivers, and the evolving standards that shape BIM maturity. Remember, BIM is not just about software, it's about collaboration, clarity, and continuity across the entire building lifecycle. Thank you for engaging with this module. If you found it valuable, feel free to comment with your thoughts or questions. Like and subscribe to stay updated on future modules. Follow the link to access supporting study materials. And most of all, thank you for being part of this learning journey. Let's keep building smarter together.